So our next unit is graphs. That's what we'll be working on. So there are a few things about graphs. We've done a few equations, and now we'll do a few graphs. So the few things that you need to know. A graph has two axes, the vertical axis or the y-axis, and the horizontal axis or the x-axis. So we'll use graph paper. There are a lot of questions with graphs on the exam, so we'll work with that as we go along. The middle point where the two lines intersect, the horizontal and the vertical line, is called the origin, or the starting point. And then we'll move on the right side and we'll count numbers as if they were on a number line. And then when we count backwards, we'll count the negative numbers. And similarly, when we move vertically upwards, we'll count the positive numbers on y. And below here, we'll count the negative numbers for y. So if I give a location, like you use Google Maps is a big fan of graphs. That's how that entire concept works. So at the backhand, sometimes when you turn on the Google Maps app, you might see a grid. You might see this, right? Google Maps, Google World, Google Earth. Although I don't think there's a Google World, but there's a Google Earth, right? So all that has a grid. So basically they're just using the same thing, right? Same idea. But they don't tell you a coordinate. They use coordinates to find your location. And then they'll say, hey, drive 3 miles north and 2 miles west and you'll reach your location, right? Now if we do that same thing on this graph, 3 miles north from your origin, from your starting point, so 3 miles north will bring you here, right? And then they're saying move 2 units or 2 miles west, so that will bring me here. So eventually, this is my ending point, right? This is what Google Maps is saying, go north and then go west, right? So in the coordinate system, we always define x before y. It's like the lettering, x comes before y. So even in the coordinate system, we use x before y, right? So what is the x value over here? It's -2. And what's the y value at this point? It's 3. So this would be the location, right? -2 and 3. Like if you took another case, 1 and 5, if I wanted to plot 1 and 5, I would go 1 on the x and y by 5 units. So I'll move 1 unit here and now I'm going to move 5 units up here. So I end up over here, right? So that's my end point, 1 and 5. So you can locate any number of points using this set of axes. Now, in the Regents exam, there will be a lot of questions. They'll give you the grid, they'll provide you the grid, right? You just have to plot it accordingly. So, and that's how you'll get your graphs. Now, the graphs that we will work on will be linear equations, which are straight lines. You'll get quadratic equations, which will be curves. And then sometimes you might come across cubic equations. You'll come across exponential equations. And we'll draw graphs for all of these. Graphs for all of these. right? Graphs for all of these, right? And then we'll have, sometimes you'll have the square root, right? Square root graph, and so on. And you might have some other things with it, the absolute value function, right? So we'll do all of these topics and their graphs, right? But there's one main concept about doing a graph, right? So there are two things that we have. We have the x-axis. Now the x-axis is the independent axis. So you can choose any value for this, right? And from the independent axis, we can get the dependent axis. So from the independent, we are getting a consideration or a representation or a relation with the dependent axis. It's like in functions, we had x connecting to y, right? So if we were to show that coordinate, it would be 1 going on to 5. So that's where your arrow is. And then you've got -2 going on to 3. Right? So that's how you would show the chart on the function part. So I don't know if that's dark enough, but that's what we get. Right? So just giving you an idea how they're related. All these topics that we are talking about, that we've discussed in the past, are all interconnected. So all straight lines will have this form of equation: ax plus by plus c is equal to 0 or is equal to c, where c is a constant value. It can be anything. And now you've got two variables. So this is one variable and this is your other variable. Right? And you can change the axes. It could be as plus bt is equal to c. So now your axes will become s and t. Right? So there's one dependent variable and then there is an independent variable. Okay, so let's say we draw a graph after you plot the coordinates and you plug in values. You get a graph like this. This is y, this is x. Now the graph cuts the y-axis at this point. We call this the y-intercept. At this point, what is the value of x? X is 0. So remember this, there will be a lot of questions. Find the y-intercept, find the y-intercept. X is 0, x is 0. They'll keep giving you, they'll have a number of questions based on these ideas. Similarly, this graph even cuts this axis. This is called the x-intercept, where it cuts the x-axis, right? And y is 0. Now for this x-intercept concept, they will ask you for this solution more than this one, right? So whenever they ask for a question like this, find the zeros of a question or an equation, zeros of an equation, or they ask you for solutions of an equation, or if they ask you for the x-intercept, or if they ask you for y is equal to 0, right? All of these things are referring to the same thing. And there are numerous questions based on this idea, right? Numerous questions. So intercept, you can remember it like in video games or something. A plane intercepts, a missile intercepts, right? Or even in the news, very commonly used term, intercept. There are wars every day, right? You will be watching a lot of that. So intercept is a word, right, that you'll come across. And these words, these keywords are important. Zeros of an equation, they'll ask you for that. Solutions of an equation, they'll also ask for solve. Solve this equation, solve for x. It's asking for the same thing. You'll get quadratic equations where one side is equal to 0, right? So you're solving the same thing. You're asking for basically the values of x. Okay? Then we'll do some concepts about slope. There's something we've studied in the past. I'm just reviewing it. So slope. So if I draw a horizontal line like this, do I have a slope? What is the slope over here? Would you say, like when you're walking on normal ground, do you ever say I'm walking on a slope? Right? Like this room, if I'm walking, would I ever say I'm walking up a slope or down a slope? When do we use that? Right? So slope. What is the slope over here? Can I say it has no slope? Right? No slope. So can I say the slope is equal to 0? Right? Now if you're going uphill or you're increasing, right? Imagine uphill. What's the slope? The slope is positive slope. Okay? So m will have a positive value. So it can be +1, +2, +½ +quarter, anything. Yeah? And now the opposite is if you were walking downhill. Then you'll have a negative slope. You've got a negative slope. So m is negative. So we've got two things. When you're moving uphill, you've got a positive slope, and when you're moving downhill, you've got a negative slope, right? And then we've got one last line. What if something's vertical, like a wall, right? Like this is your floor. Imagine this to be your floor, this to be your wall, right? Your wall is vertical. What is the slope? The slope is a maximum, or it's equal to infinity. Such a large slope that you cannot probably climb it, right? Unless if you use a tool or something, right? Something to get you up to that level. So that's how you get that slope, right? It's at maximum or infinity. So zero slope when it's horizontal, maximum slope when it's vertical. When you're going uphill, positive slope. When you're going downhill, negative slope. So like if you were going up a mountain, you would go this way, right? And then you'll reach the peak and then you'll come down, right? If we are talking about slopes, that's not a shape of a mountain, but if you have a flat bed like that at the top, then you'll have something like that. So what would your slopes become? This would be positive slope, this would be zero slope, this would be negative slope, right? So you've got some slopes happening here. Now how do you solve them? How do you solve for a slope? So I'll give you a formula and then we'll do some basic tips about it, okay? So, the formula for slope is vertical change or change in vertical axis divided by horizontal change. Right? So two things. In some books you might see it this way. So the symbol for slope is m, and change in y or change in vertical axis divided by change in horizontal axis. This thing's called, it's a Greek letter called delta, which means change, right? It's a mathematical symbol that we use and we call it change. So, how do we find a slope? So if we have a line like this, right? What we can do is take any two random points on this line, as long as they're on the line. Let's say if I'm taking this point and I'm taking this point, right? And these are arbitrary, so you can choose and it's up to you, right? You can choose these. Now let's draw a line from here such that it's horizontal, and then let's draw a vertical line over here. So you see this right angle triangle, right? See this right angle triangle. So that's what we are trying to make every time. So you see 2 points, you make a right angle triangle, and you get these 2 points, right? We see a vertical rise over here. We see that it's rising, right? And here we see a run, which is delta x. So our slope is equal to delta y over delta x. So for example, if I were trying to find the slope of these 2 points, right? I could do that same triangle thingy over here. So this is my 90 degrees. Now this is at level 3, right? And this is at level 5. So how much did it increase from 3 to 5? From 3 to 5 that we are observing here. It's increased by 2 units, right? And similarly, we are at -2 here, and we are going to +1. So how many units am I moving? 1 unit, 2 unit, and 3 unit. So what's the slope of this line? The slope is the vertical change. Remember to write this formula. It's always going to keep you in the direction. You won't get confused which number to put before. It's always y divided by x. So we'll have +2 divided by 3, which is 0.6666 if you would like the decimal value. So remember this, whenever we want a slope, we want this right angle triangle. That's what we are looking for, the right angle triangle. Okay? Okay, then we will discuss how to use these slopes and how to write certain equations. So now the equation, the standard form, the slope intercept form of an equation is y is equal to mx plus b, where m is your slope, y is the y-intercept, x is your horizontal axis, and y is the vertical axis. Okay? So y is equal to mx plus b. This is always the equation of a straight line. So whenever you find out a straight line, like when you are transitioning, you're doing a straight line, that's what you're looking for. Y is equal to mx plus b. If you can achieve that, it would be a straight line. If it's not mx plus b, then it's just a scatter plot, which we'll talk about later. Now sometimes you might have graphs which are like this. So I'll make a table and I'll use that to explain my idea. So let's say if you're doing math, right? Like as you do in your class. And it takes you 5 minutes to solve each question. And let's say if you're solving 4 questions, right? So, now which is the variable, right? The questions. And the questions will help you determine the time, right? So let's put the questions up here on the x-axis. Could you do 0 questions? When you decide not to do any work, could you do 0 questions? Right? Could you do 1 question? You could possibly do 1 question out of 4, right? And you could give up. Could you do 2 questions? You could attempt 2 questions, right? Could you attempt 3 questions? Or you could attempt 4 questions, right? Now, if you look at the time, let's say if we'll put these in, let's use a different color, time, right? So if you do 0 questions, how much time would you require to take to do 0 questions? 0 minutes, right? What about 1 question? You'll take 5 minutes. For 2 questions, you'll take 10. For 3, you'll take 15. And for 4, you'll take 20 minutes. Now, such a sequence or such a relationship is called a direct variation relationship. Direct variation. So what happens over here is that this thing is increasing, and because of this increasing, this value also increases. Like for example, if you had a job and you were getting paid per hour, you might end up taking a job in the future. So if you decide to do that, you'll notice that the more hours you work, you'll end up making more money. The less hours you work, you'll make less money, right? So if you decided not to take up a job, so you work 0 hours, will you make any money? Probably $0. But if you work 20 hours, you'll get a certain amount of money. What if you work 40 hours? What if you work 60 hours? Right? You're indefatigable and you want to work 60 hours or 80 hours or 100 hours. You'll end up making a lot more money. Let's plot this graph. Let's see what we get. So, we'll have our questions on the x-axis. Let's name it as Q. And let's name this as T. Yeah? So, what questions do we have? 0, 1, 2. Let's say we are depending on the question. So, this is my axis. And on the y-axis, I would have 5, 10, 15, 20. We could also plot the graph by putting t on that axis if we consider time as our variable, as our independent variable. So let's plot this. What do we get? 0, we get 5, we get 10, we get 15, and we get 20. Now we can draw a straight line through it. Not the best straight line, but you can get that straight line. You've got a ruler, you've got a grid, right? So we get a straight line like this. Because it's time, I would never draw in the negative, right? Because time can never be negative. So time can start from 0 and it can go on, but it can never be negative. Now what if I wanted to find the slope of this thing, right? As we stated before, we can choose any 2 points. Let's take easy points. I'm going to take this point and I'm going to take this point. And let's make our right angle triangle, right? So on the horizontal axis, I'm going from 0 to 4, so my change is 4. And on the vertical axis, I'm going from 0 to 20, so my change is 20. So what would my slope be? Delta y, which is 20, divided by delta x, which is 4. So I'm going to get 20 over 4, which solves to 5. That's my slope. And how can I get the units? Right? I'm getting 5 minutes because this is in minutes. I'm dividing the minutes by the questions, so it would be 5 minutes per question. Could I find the other way, the question per minute, right? How many questions are you doing per minute? You could also do that, which you normally end up using in like typing skills and stuff like that, where you draw, where you find words per minute, right? So you're taking words per minute. Here you could do questions per minute. So same idea. If you took the questions and you divided it by the minutes, you would get questions per minute. If you did time per question, then you would get how much time you're taking per question. So it depends how you're determining your variables, okay? So this is something that we will be working on. They'll ask you a lot of questions about the slope. Okay. So that's the idea about the slope. And then parallel lines have the same slope, just a concept. Any two parallel lines will have the same slope. Same slope. And perpendicular lines like the x and y axis, their slopes will multiply, let's say m1 and m2. If I multiply these two, I get -1. Now the 4 most common lines that you might come across are this. If I get x is equal to a, let's say a is here, x is equal to a will be a vertical line, right? Then y is equal to k will be a horizontal line. And then y is equal to mx is passing through the origin. This is the direct variation. And y is equal to mx plus b will be like this. And here we've used m to be positive. If it were negative, it would be like this. So this is when m is negative. Right? And this is the same case when m is negative. Okay. And then we've got some graphs. I'm going to quickly draw those, and we'll get a few things done, and then we'll solve questions, okay? So that's the idea. We'll do some axes, we'll do some graphs, we'll do some regions questions. So whenever you see a grid, on your Regents exam, they want you to plot the graph. So the best thing you can do is make a table, choose values for x, your choice. Use small numbers like -2, -1, 0, 1, 2, right? And plug in the value in the calculator and you'll get a set of values for y. And you just plot these, right? The other option is on your calculator, you've got the screen is up here. And then you've got this button with y is equal to. So you can plug in your equation and in the corner you'll have a button with graph or table. So you can see what your graph looks like or what's the representative. So a few questions that we might come across are a few standard graphs. I'll draw the shapes. We'll do it more frequently by taking values and by drawing the actual graph. So the first graph is y is equal to ax squared plus bx plus c. Remember, whenever a is negative, we'll get a mountain. So your graph will be like this. If I were given a as positive, then I would get a valley, the shape, right? So this is whenever you have y and an x squared, you'll always end up getting these shapes. Now what if I changed it to y squared and an x? So I squared the y. This will flip. So your graph will end up this way or this way, right? Remember the vertical line above functions. These are not functions. These are not functions. These are not functions. Malfunction, malfunction, malfunction. Remember? These are functions. If I drew a vertical line, this would work, right? So this is something we've discussed in the past. So these are some graphs you're going to work. You're going to have a lot of questions based on that. Then another graph you will have is the absolute value function. So absolute value is something that makes everything positive. Like the staff here, your teachers, your friends, some of them, right? So what they do is they look for positivity, right? So even a negative value becomes a positive. So if I had y is equal to absolute value of x, how would I draw that graph? So I take x and I take y and I put in values for x. So when I put 0, I'm going to get a 0. When I put 1, it's already positive, so I should get positive 1. When I put positive 2, I should again get positive 2. What about when I put negative 1? Now this is like a machine that changes everything that's even negative into a positive, or if it gets a positive, it retains that positive. So the negative 1 will become plus 1, negative 2 will become 2, and then you'll get 3. Now what if we plot this? Right? So we've got 0, 1, 2, 3. 1, 2, 3. So at negative 3 we are at 3. So negative 3 and 3 we come up here. Negative 2 and 2. Negative 2 and 2. 1, negative 1 and 1. 0 and 0. 1 and 1. 2 and 2. 3 and 3. So we get this V-shaped graph. Whenever you get a V-shaped graph, it's always using absolute value function. Okay? Then we've got the exponential function, which you've done in geometric series and stuff like that. So anything that increases exponentially as an exponent, like if you have 2 to the power x, right? Let's make a table. Let's put in x as 0, 1, 2, 3. Let's use some values really quick. Now if I put 0 up here, what's 2 to the power 0? It's 1. What's 2 to the power 1? 2. What's 2 squared? 4. What's 2 cubed? 8. If I plot all of this, I get 0, 1, 2, 3. Let's take 2, 4, 6, 8. Right? You see a different axis that I considered based on the question. You've got to make these decisions based on the information that is given to you. Like if the question had thousands in it, why would you start from 1, right? You can jump from 0 to 500 or to 1000 and stuff like that. So at 0 it's 1, so let's mark it up here. At 1 it's 2, at 2 it's 4, and at 3 it's 8. So we get a graph like this. So it is an exponential graph, okay? Anything with an exponent will have an exponential graph. So remember that. And this always, normally it cuts through 0, 1, okay? And then you've got graphs like the piecewise function. Piecewise function. So let's look at a piecewise function. Let's say we have this, okay, piecewise function. Till 3 it's like this, right? Till 3, 1, 2, 3, 2, 4, 6, 8. Right? So it goes like this. Till 3. And beyond 3, beyond x is equal to 3, or if I write it x is greater than 3, your graph is y is equal to 8. So it becomes a constant like this, right? And then we'll talk about inclusive and non-inclusive terms. Let's use an inclusive term right now. So we'll shade this, right? So whenever the term is part of the graph, which means inclusive, we'll shade the circle. If it's not part of the graph, we'll use an empty circle. So if it was shaded, then we'll say that it's part of the graph, otherwise it's not part of the graph. Okay? And then we'll do one last question, which is called the step function. Now, how does the step function work? Step function. Something like this. You'll see this. So the graph is more or less like a step. Imagine a step. So the graph will look like this. So there will be an inclusive and a non-inclusive point, inclusive, non-inclusive, inclusive, non-inclusive, non-inclusive, inclusive, non-inclusive, inclusive, non-inclusive, and stuff like that. It looks like a step. And this is how you would do the step function. Alright? So this is all we need to know about graphs. Another thing about the x and y that we've discussed earlier, there are two words for it. This is called the domain, and the y values are called the range. So some questions, we even discussed it in functions. Some functions or equations or graphs will ask for the domain. So you give the x values, right? If it asks for the range, you give the y values. So good luck. We'll do a lot of questions. Graphs, again, are a big concept, big idea, a lot of questions. There will be a lot of questions on graphs. So be prepared to solve. All right, good luck.